Hello guys, in this video I am going to introduce you to this self-play fine-tuning or spin in short technique of fine-tuning. Fine-tuning of large language models or LLMs is like teaching a well-educated generalist to become a specialist in a specific area. Initially, LLMs learn from a vast range of topics, understanding language and knowledge broadly. Fine tuning is the process where the model is further trained on a specific dataset or to perform a specific task. This specialized training helps the model to perform better on tasks related to that specific dataset or task, making it more adept at understanding nuances, jargon, or the particular needs of that domain. Now, as an example, imagine that you have an LLM that knows a little bit about everything, like a super smart generalist. You want this model to become an expert in medical information, providing accurate and helpful responses to the health related questions. Fine tuning in this case would involve taking this generalist model and training it further on large data set of medical textbooks, research papers and health forums. By doing so, the model learns the specific language, terms and types of questions and answers that are common in the medical field. After this specialized training, when you ask the model a medical question like what are the symptoms of diabetes, it can give a more accurate and detailed answer based on its enhanced understanding of medical knowledge. This process of fine tuning transforms the model from a jack of all trades into a master of one, making it much more effective for tasks within the medical domain. And you might have guessed, you can fine tune a general model to any set of data and to make it a specialist in any field of your choice, whether it is your company's own data or any other specific field. So this is what fine tuning it. Now this project, which is called a spin, they have come up with one of the most exciting recent advancement in terms of fine tuning. So how spin works is that it fine tunes a base model using pairs of instructions and answers, and then they use the model to generate prompts based on seeds from the instruction dataset, or in other words, n candidate responses for every prompt, and ask the model to assign them a score between 0 and 5. Then they use DPO fine tune, and by DPO fine tuning the model, they use previously created dataset. So in other words, model generates its own training dataset in every iteration, learns from the previous iteration, and then self evolve itself. You can use the same approach several times to compare different iterations of the model and gradually improve the performance, as you can see in these figures. For example, if you look at this one, what is happening in this one is that this is the average score of spin at different iterations on the Hugging Face OpenLLM leaderboard, and you can see that it is improving with each iteration. Now, if you look at this diagram, this is showing you performance comparison with DPO training across the 6 benchmark dataset. Spin at iteration 0 um, sorry, so spin at iteration 0 achieves comparable performance to DPO training with 62k new data. At iteration 1, spin has already surpassed DPO training on the majority of dataset, and the performance only improves, as you can see, on each and every iteration on all the benchmarks in this figure. Okay, now the story doesn't really end here. They also have a paper which is a really delight to read. I already have given you a synopsis of it, so I will let you read it. One thing I wanted to show you this example where we have this ground truth. This is an example of ground truth completion compared to the fine-tuned model generation at iteration 0 and 1. Now give it a minute to read through it, and then you will see that we can observe that the model generation at iteration 0, although fluent, incorrectly quantifies transportation preference with specific percentages that are potentially hallucinations. The model generation at iteration 1 provides a qualitative summary of the transportation forms at Southampton without specific percentage, aligning more closely with the ground truth while adding more detail. So all in all, a real good project. And as I said, that what they have done is, the researchers, they have also open sourced the code on the GitHub, and I'll drop this link to this GitHub repo in video's description. I tried to install it my local system, but it failed because if you go through this GitHub repo, it uses A100 multiple GPUs, and all of them are A100, which I don't have access to. Okay, but I can at least walk you through as how to install it. All you need to do is to install Conda in your environment. If you don't know how to install Conda, I have another video where go into the detail. Once you have installed the Conda, create a virtual environment, activate that virtual environment, then install all of these prerequisites, which is Torch. And if you are using CUDA 11 or above, you should be good to go with this. And you can use nvcc-version command to check your CUDA version. If you are using any CUDA version below 11, then you need to upgrade it. Okay, and then git clone this repo, which I'll drop the link in video description. And in order to grab the link of this repo, let's go quickly up, click on this green button and grab this URL, spin.git. Okay, once you have it, come back here, git clone that repo, and go cd to that repo's root directory, working directory, and then pip install everything, and then install flash attention. Then go to huggingface.co, get your free token with your email, and then log in by replacing your token here. Once you have done it, then you can either generate your own data or just go with their own data. So directly go to step 2 fine tuning, this one, install pip, install accelerate. This should have already installed by the requirement, and then launch this one. As you can see, they are using multiple GPUs, and I think this is quite heavy too. So anyway, so make sure you have access to the beefy system. Once you have it, you can launch the fine tuning of your model on the basis of it. Now the model which you can use is, just simply go above here. For example, by default they are using this Zephyr 7 billion SFT full one, but you can use your any one of these from here. So that's it, guys. I hope that you enjoyed it. Let me know your thoughts on this technique. I'm more than sure that this is going to be one of the most important advancement this year in terms of fine tuning. Share your comments or thoughts in the comment section. And if you like the content, please consider subscribing to the channel. And a personal request, and do me a favor, if you like the content and if you're already subscribed, please share the channel and post among your network on social media, WhatsApp, Twitter, Facebook, or wherever you like, because it helps a lot. Thanks for watching and support.